Hello, guys. I am Dr. Praja, and I am very excited to solve with you an AP statistics problem of inference. Let's see what's all about. Advertisers study the effects of television ads on children's choice for two new snacks. There are two types of snacks, choco juices and apple juices. For this purpose, an experiment is set up. So 75 children are randomly assigned to three groups, A, B, and C. Each child will watch a 30-minute TV program and 5 minutes of advertising. The advertising for the first group A will include the Choco Juice ad, but not the Apple Juice ad. The advertising for group B will include the Apple Juice ad, but not the Choco Juice ad. Finally, the advertising for the last group C will include neither the Choco Juice and nor the Apple Juice ad. After the program watched television and the ads, the children were offered choice between the two snacks. Their answers are summarized and their choices are reflected by the table on the screen. At this moment, I want you to suggest to pause the video and to try to fully understand the state of the problems and to try by yourself to reflect on each information that is given, what can be useful for you in order to solve the problem, to answer to the first question. At the same time, during the video, I encourage you and I suggest you to pause the video anytime you feel is necessary to study mindfully all the resources provided and to take your time to do this because all the resources will be, as you can see, a great tool for your exam because they are consistent with the College Board and AP exam. And I like to believe that they are well done to support your learning. So I hope that you did this before. So let's go to read together the question. Do the data provide convincing statistical evidence that there is an association between the type of ad and children's choice of snack? So as you can see here, every time when you have a problem, when they ask you if there are convincing statistical evidence to infer an association or to check a claim or whatever type of question it is of this genre, you should think at inference. So it's a classical problem of inference. But what time or type of inference should be used here? Because we have inference for proportions, for means, we have chi-square test. So let's see, let's take a look of what we already know from the problem, what we already selected. So what is important here is that we can identify two types of categorical variables, type of ads. We have two types of ads, and also we have two options for children's choice when regarding the new snacks. Another feature that is important is that an experiment was set up, and we have three groups and three treatments. So, because of the fact that we have multiple data, we should think on the numbers, proportion, categorical data. We should think at the tests that involve plenty of data, and of course, these are the chi-square tests. Also, the word association. because this is the question to see if we have enough convincing statistical evidence to conclude that will be an association or not between two categorical variables. So association makes us to believe that lead us to the conclusion that we might have a chi-square test for association, because here specifically we check the association between categorical variables on one population. So let's reflect on this. It seems to be like this because we have two categorical variables, type of ads and children's choice. We have one population of 75 students, but at the same time, if we reflect more what we have in this problem, and it's considerably important in statistics, we set up an experiment. We assign treatments to group. So it was to take a look to the third type of test that refers to check differences for two plus population. Here is a two plus population, so more than two plus population, or treatments for one categorical variables. And this seems to be more appropriate because basically we have three treatments and one categorical variable. We can consider the children's choice for a specific type of snacks to be the categorical variables, and we can consider also the three treatments. So that's why the most appropriate approach here will be uh, to choose the chi-square for homogeneity. But don't be scared and don't worry. If you choose the chi-square for association, you are still good for the AP exam. And let me show you here a comment is acceptable with the right hypothesis, but we'll reach out there a bit later. So I want for you guys to pause the video and to study all these conditions in an appropriate pace, to be sure that you understand when to apply it, what procedures, the name of procedure, how to write the hypothesis, the null and alternative, what conditions to check in order to apply a specific procedure, and how to do it, what is the mechanics. Also, you have here another resource that is valuable, and I want you to pause the video and to study this resource. Although it's about expected counts, how to calculate expected counts in a one-way table or two-way table. You have the formula. And the most significant part for us in statistics, what conclusion to infer. Uh, how to formulate this conclusion. This framework will help you to formulate accurately this conclusion for the AP exam. Another thing that is important for you to understand is to I try to reloop a few definitions for you, because we use a lot this definition when we talk about chi-square statistics. So we refer to categorical or qualitative variables, and we refer also to quantitative variables. So be sure that you are aware of the key features of these variables. And also we use the word distribution, because usually when you hear the distribution, you are tempted to think only on the normal curve. So now, by the meaning of the distribution in general in statistics, is refers to the values of the function that can show you all the possible values for a variable, and how often they occur. So this is the meaning of distribution in the sense that we'll use here, as you can see in the definition. So that's why I suggested to do this, because basically what you have here summarize what you studied, guys, in Unit 8 in statistics. And it's a great tool to have this unit fixed, because at exam, most of the time, chi-square tests are present. They are a very modern tool that is used in many domains, in many fields, when we statistical researches are made. So let's go back now and to our problem, and let's try to perform the test of inference. So as I said, we decided to the chi-square for homogeneity test due to the fact that we deal here with treatments. We deal here also with categorical variables in our vision for the chi-square for homogeneity. The categorical variable will be the children's choice for snacks, for one or other type of snacks, and that's why we will analyze the differences that are made by the treatments, because this is the sense of the question of the problem. Can we find an association, a connection between the type of ad and children's choice of snacks? So the logic of the problem is that first we have the type of ad, and this is the logic of our problem, due to the fact that we assigned treatments to each group. So basically we assign the type of ad at the beginning, and then we will study what's happened with the children's choice of snacks. So this association, it's a type cause and effect association. So it's not, there are not two separate categorical variables that can be associated. They are influence, the first influence the other, and this is the logic of the problem. So that's why we will study if there is difference. It's normal to study better difference than association. So this is another reasoning for why I opt out for the chi-square for the homogeneity. So respecting the framework that is given here, the framework for null hypothesis should sound like this. There is no difference in distribution of the categorical variable across treatments. Now you should adapt this for your problem. There's no difference in distribution of the categorical variables, as we said, for us are the children's choice for snack, and the treatments refers to the ads that they watch in the three groups. So that's why our formulation should be adapted in each problem, in fact, to the context of the problem. So adapting this, it sounds like here. There is no difference in the distribution of children's choice of snack who watch the Coco Juice ad and the distribution of the children's choice of snack who watch the Apple Juice ad. So these two distribution should be compared in order to establish if there is an association between ad and student's choice. We should compare this distribution. If you like more, the distribution can be expressed by proportion of children, because you will have a table where you summarize some observations, some observed outcomes, and you can calculate the proportion of children's choice of snack who watch the Coco Juice ad, and you can compare with the other proportion. So this is H0, null hypothesis, and alternative hypothesis. Alternative hypothesis is an immediate consequence. The typical formulation is there is a difference in the same distributions. If you look at the College Board AP exam solutions, you will find the formulation of null hypothesis and the alternative hypothesis very refined, so very focused. But this is the expression of a long practice and of the professionals. So if we read this now, you will see that this represents the same thing that we see above. But to formulate and to refine first statements like null hypothesis and alternative hypothesis in the standard form, to refine and reformulate in a more refined form, as I told you before, requires experience. So that's why I suggest you, because you are at the beginning, to be sure that you write first this null and alternative in the standard form, and you can let them like that. You are perfectly fine. But if you are passionate about reformulation, about wording, and about to have a short statement, you can then check the second one. So let's check this one. Null hypothesis. The proportion of children who choose each snack is the same regardless of which type is viewed. So here it's clear that the message of null hypothesis is the same as we formulated at the beginning, because there is no difference between these two distributions. But of course, the wording is very short. But as I told you, this is the expression of the professionals. But for you, I think, just to be sure that you are formulate correctly the null and alternative hypothesis, I suggest you to respect this framework that is here. And when you feel confident, of course, you can try to refine the formulation. Now, because we already completed the state of the null and alternative hypothesis, we identified the procedure is the chi-square for homogeneity. We have to check the conditions. So looking at the conditions, we have independence. So we need to check if the data are coming from a stratified random sample or a randomized experiment. You might take your time and you can check the conditions, try to stop the video and to reflect by yourself to see exactly what will be your vision, and then we can check together. So let's see. In our problem, we deal with a randomized experiment, because remember, the word experiment is in the stem of the problem. We assign treatments to 3 groups. So it's not a stratified random sample, but we have a randomized experiment. So this condition is fulfilled. The second condition, 10%. When sampling without replacement, the number, the 75, should be lesser than 10% of the whole population. And we can assume this condition to be fulfilled because all the children population, of course, that is greater than 75, 750, or even 800 children. So that's why we can assume this condition is fulfilled. The large count condition refers to all expected counts to be at least 5. For the expected counts, as you can see, we have formulas for one-way table of two-way tables. Two-way tables means a table that has rows and columns, and this is our situation. So the formula will be total row times total column divided by total table. So let's do these mechanics to calculate the expected count, because this is the last condition that we have. So we'll start first with to complete our table that is given in the problem, because remember, we have only the observed input in the original table. So we need the expected input. So that's why we will calculate expected for each data from here. And also, because we have 3 rows and 2 columns, we need the totals. So be sure that you add a column, you add a row where we will assign the total. We will calculate. So for the first row, we have a total of 21 plus 4 observed, that means 25 children. Second row, check the total, 13 plus 12, again 25. Third row, total 22 plus 3, again 25. So basically the total table is 75, and this fits with the sum of the problem because we had 75 children. But it's a two-way table, so we have totals of row and on rows, and we have totals of columns. So this is the meaning of two-way tables. If we check on columns, 21 plus 13 plus 22, we have a total of 56 for the number of students who chose Choco Juice. If we add up and summarize, so the number of children who chose apple juice, the observed values are 4 plus 12 plus 3. We have a total of 19. Finally, the total table 56 plus 19 will be 75, so we are good. If it won't be 75, just be sure that you check again the totals because it will be a nonsense, so you should have somewhere a mistake. Now we can calculate basically the expected count. So again, total we said, and let me show you again, expected counts in two-way tables. Total row times total column divided by total table. So I use the colors here to help you to watch this. So total row, first row, I'm calculating expected counts for this observed value of 21. Yes, total row is 25. Total column, where you have 21, you see it's 56. So total row times total column divide by total table, that is 75. You can calculate, you have 18.67. For the second value, the same. So total row, you have 25. Total column, look where is your data, and you look on the column, you have the same total 56, divide by total table. So you'll do the same for each value here. Of course, here for the value of 4, you have total row. The row is the same, 25, but the column where is this value 4 is 19. So that's why here we'll have other expected values like 6.33. So what you need to write at the exam, you should calculate and the expected value for each category, and you should write that uh, as a conclusion that the least expected value is 6.33, so it's greater than 5. So that's why the expected value condition that is specified on conditions is at least 5, so it's fulfilled. Now we'll go to the next step, number 3. We will calculate the test statistics, the chi-square test. So we usually have two ways to calculate. First way is using the calculator, and let me show you how you use TI-84. So on TI-84, let's go first, let's quit here. So let's quit to here, and first we'll introduce the observed values. Because we have a two-way table, we need a matrix. You have the button matrix here, so second and matrix. And here you have two matrices. The first will be for the observed value. The second one will be calculated automatically by the calculator and will provide you the expected value. So for you will be enough to insert the observed value. For this one, go to edit. So go on the right until you reach out and edit the first matrix. So let's enter. Here are the dimension of matrix. So 3 rows, 1, 2, 3, and 2 columns, exactly as in the initial table. So this is set up. If you want, you just insert here other numbers and then, by example, 4 or whatever. And if you click enter, they will show you a matrix with 4 rows or whatever do you need. But I will go back and I like 3 because I already inserted for you guys. I inserted this matrix, the observe values 21, 13, 22, one by one in the matrix to gain time. So basically we have the matrix. Once as you inserted each value and you click enter for each value that will be inserted in the matrix, then you can go to stats and perform the test. So be sure that you scroll on the right until you find the test. Here you have all the inference tests. Be sure that you scroll down to see all the tests until you find the chi-square. And I will scroll to show you how many tests there are here. But our chi-square test for homogeneity or association will be this one from C. So go back until you reach out to C. This is our test and click enter. At this moment, they will specify the observed values here are in the matrix A, expected in the matrix B. So just scroll down. We said already this and go and calculate, enter. And finally, you have the value of the chi-square test. So you have plenty of decimals. Remember that on exam, you will round to using only 3 decimals. So if you look here after the third decimal, you have a 3, so a small digit. So that's why you round to 10.291. This will be the first round. And you have also the p-value. This also should be rounded to 2 decimals, but because the p-value is 0.0058, you need 3 decimals. After 5, you have a big digit, you have an 8, so you round up. So your p-value rounded will be 0.006. So this is basically the probability value. So the probability that chi-square to be greater than the chi-square value calculated will be this one. So now you can formulate the conclusion. But I want to explain also the mechanics of the chi-square test, because many times on the exam they asking you questions that refers to this formula to check if you guys understood the logic that is behind, if you have critical thinking, if you understand the statistical reasoning process or the mathematical that is behind all the inference procedures. So that's why I will discuss the second way to calculate the chi-square by arithmetic approaches, analytical approaches. So we have a formula. You will see everywhere this formula is the same formula that you will apply for all the chi-square tests. If you look here at association and homogeneity test, you have basically the same. That's why it makes sense, as I told you, if you apply guys association test, you'll be also perfectly fine. So the formula states that chi-square is obtained by summation of the difference of observed minus expected square, that's why it's called square, divided by expected. And you'll do this for each pair of observed and expected outcomes that you have in your data. So for the first one, 21 minus 18.67, observed minus expected, square divided by expected. So this is what we have on the first fraction. Second fraction, you go to the next pair of data. Observed, expected is exactly what you have here that you plug in the formula, square divided by expected, and so on. You'll do this for all 6 pair of observed and expected values. So you should have 1, 2, 3, 4, 5, 6 fraction, as you can see. If you calculate separately, you will find then by summarizing the value of the chi-square statistics. But as I told you, you might have question like this: what values contributes more to the chi-square statistics? So basically, you should look at the fraction to see which one has the greatest contribution, and you'll find the last one, or other questions that are related to the mathematics that is behind this formula. Of course, you can finalize this problem using also the chi-square table that you have in the exam paper that you'll receive. And let me show you how to use this chi-square test. So it's at the end of your subject. You have the table for the chi-square. This is the general shape of the chi-square distribution, but of course this depends on the degree of freedom. A degree of freedom should be calculated and then should be used by selecting here the appropriate degree of freedom. Let's see, because when we see I-84, this degree of freedom wasn't necessary because it's given here, degree of freedom equal to. So the calculator can provide you. But how do we calculate degree of freedom using analytical approaches? And because we need to know, by example, to know where to look in the table. So if you go back to our resource here, you might see here that for the homogeneity or also for association, degree of freedom is given here, number of rows -1 times number of columns -1, because it's normal, you have a two-way table, right? So count the number of rows and numbers of columns, but I suggest you to count this from the original table, because not from the enhanced table that we made in the solving of the problem. So here, if you look, you have 3 rows and 2 columns. So basically, coming here, you have 3 minus 1, that is 2, times 2 minus 1, that is 1. So 2 times 1 is 2. So that's why using arithmetic analytical mechanics, you find the degree of freedom 2. And the probability that the chi-squared to be greater than the value that you obtain will be given by this value. And let's see, where is this value in the table? So why we said here chi-square test greater than this value, because as you can see, the chi-square table, they give you in the table the probability when the chi-square is greater than the threshold that you calculated. So it's a tail probability. It is called a tail probability. So we set degree of freedom 2. So here is the degree of freedom. Let's look for our chi-square value that we have here. So approximately we had 10.291. So our value will be here between these two, but very close to 0.005. So could be 0.006, 0.007. The table doesn't give you the specific value, but anyway, you don't choose probably 0.005. You estimate the difference here, and you can choose 6 because it's close, or maybe 7. But that's why, to be sure, I suggest you to use also TI-84 is the first recommendation to use. And if you have specific question about the mechanics and reasoning behind, you use these tables and this formula. So basically, this is our formula. And our probability is 0.006. We are now able to formulate the conclusion because we have the p-value. Let's go back to our resources, because here you have also another framework that is very cool when you formulate the conclusion. And I will try not to apply mechanically this framework. I will try to explain the reasoning behind, because in this way you can remember and you can formulate the conclusion accurately and remember what conclusion you should infer. So because the p-value is, and here you just complete with the p-value that you calculated, for us is 0.006. So our p-value, we compare if it is lesser or greater than the significance level 0.05. In the problem, it's not given any threshold, any level of comparison. And when it is not given, it is you should compare with this significance level that is used in statistics, 0.05, or even the more conservative version of this, that is 0.01. So for our problem, because we have 0.006, we are on the first version. So our p-value, our probability, is lesser than the significance value. So the meaning is the probability is small, very small. Probability means chances that something to happen. For our problem, the chances that null hypothesis to happen, because this is the goal of the test, to check if the null hypotheses have chances to happen. That's why we formulate null hypotheses separately. So because we have a small probability means chances, small chances, null hypothesis to happen, that means that there are not many chances to happen, so that's why we reject null hypothesis. Because again, there is a small chances that this should happen. Small probability means small chances, so reject the null hypothesis. This is the term that you should use in the problem. And then because you reject null hypothesis, it's logically that you conclude that there is significant statistical evidence that alternative hypothesis is true, because you reject null hypothesis. So you have enough, significant, not enough, because never it's enough. In statistics, you know, guys, that plenty of data means success. So plenty of data means more accurate inference. So that's why don't use the word enough, use significant, okay? So there is significant statistical evidence that alternative hypothesis is true, because you just rejected null hypothesis. And this means, and here you should come with the context of the problem and to formulate. So this is the framework in that you work. So I try to explain the reasoning. Now let's go back to our problem, and let's see exactly how it will be our conclusion for our problem. So reading again the problem, let's look over to revise the null hypothesis. And it was a good thing to state the null hypothesis, guys, at the beginning, because during the process we lose the goal. So here is our goal, to check this null hypothesis. The proportion of children who choose this snack is the same regardless of which type of ad is viewed. So there is no difference, as we said, between the distributions. So let's see, what do we have? Again, our p-value is 0.06, so it's lesser than 0.05. So we have a small p-value, so we reject the null hypothesis. So that means, let's formulate this, because the p-value is smaller than 0.05, or you can consider 0.01, whatever, you reject the null hypothesis. So there are convincing statistical evidence to consider the alternative hypothesis, and in the context of the problem, this refers to what? The data that you have provide convincing statistical evidence that the proportion who choose each different snack differ. There is a difference, right? Because this is what we stated. On H0, there is no difference between the proportion. On H alternative, there is a difference. But remember, rejecting the null hypothesis means there are convincing statistical evidence that alternative hypothesis to be true. That means there is a difference between the proportion of children who choose each snack based on the type of ad that they view. This was the first question. The second question. It's also a tricky one. It's a tricky one. Write a few sentences describing the effect of each ad on children's choice of snack. So again, every time on statistic, read the problem slowly. Don't rush on them to be sure that you make sense and you got the message. So the effect of each ad on children's choice of snack. So this is like the effect and this that ad has on children's choice of snack. So that's why we will report to ad to see what the effect could be. So let's watch the ad here. Here are the ads that we apply to different treatment groups. So let's start with neither ad. If you have neither ad, what can you say? You can say that 22 out of 25 from this group, right, will choose, what will choose? Choco Juti snacks. So the proportion is 22 out of 25. Use a calculator and you have 88% of children who chose Choco Juti snacks. These are CZ from Choco Jutis, you know already. And the other proportion, 3 out of 25, calculated, you can calculate 100% minus 88% is 12%, whatever you want, you will find 12%. So this represents the proportion of students who chose Apple Jutis. Apple Jutis. So basically, when you state the conclusion, you will formulate, right, by expressing this proportion and preferably in words, right? So 88%, but you'll show, of course, how do you found 88% of children who chose Choco Jutis, comparing with 12% of children who will choose Apple Jutis if neither ad was viewed by the children. Then the second impact, the second effect that we'll study is the impact of the ads. If we have a Choco Jutis ad only, so the proportion of students, of children who chose Choco Jutis is 21 out of 25. So basically, you have 84% of children who chose Choco Juti snack while they'll watch Choco Juti's ad, comparing with the 4 out of 25 students that represent 60% that children that chose basically Apple Juti snacks while they watch Choco Juti's ad. So what will be your conclusion? Because the conclusion again refers to what? Effect of each ad has on choices. So comparing neither ad with Choco Juti's ad, we can say that this ad of Choco Juti's is basically not too very relevant because the proportion is it's very close. They are very close. So this is the effect of ad. So this is the hidden message of the question. because they want you guys to study the effect of ad. And this makes sense, right, in real life. It's important to know if an advertising is good or should be replaced or should be improved or whatever. So the conclusion will be when the Chocojuti ads was viewed, so we are here, 85% who chose Chocojutis is similar with the percentages that of the students that chose also Chocojutis when they didn't have neither ad. So, conclusion, watching the Chocojutis ad did not affect the snack choice very much. Did not affect because, as we can see, the proportion are very close. 84 is close to 88. And finally, the last one, the apple juice ad. Let's see the effect of apple juice ad. So if you go on the table, apple juice ad, 13 out of 25, we have a 12 out of 25. So 52% now will choose the choco juice snacks, and the others 48% apple juice. Of course, comparing this with neither ad, if we do not have neither ad, the preference is for choco juice. But what happens when the children are watching the apple juice ad? As you can see, this ad is very effective because it increases very much the proportion of students who chose the apple juice ad and decreases the proportion of students who chose the choco juice snacks, right? So that's why we conclude that this apple juice ad is effective, and you should try to formulate this, right? So the conclusion, yes, will be that watching the apple juice ad seemed to increase the proportion of children choosing apple juice. So, as you can see, as a final remark here, use all the time approximate words that are describing approximately. Don't say will certainly will increase. No, no, we do not accept this in statistics because remember we had an experiment, we had a sample, so we infer in the base of the sample, but we can infer that seems to increase. So in real life for the whole population, we are very confident that the proportion this will increase, but we cannot be 100% confident. Remember and connect this, of course, with confidence level, with significance level, right? So the significance level 0.05 can be related with 95% confidence level in a confidence interval if you want to use this procedure. Okay, guys, this was the lesson for today, and I hope that my explanations help you to make sense on how statistics works on inference problems for the chi-square test, and I'm pretty confident that the resources that I created here will be a great help for you in order to understand the chi-square test. Thank you for watching this lesson, and I wish you guys a lot of success at exam. So it was nice to stay with you, and keep the finger crossed for you. Thank you for watching this video. Bye.